we have synthesized so you all know the basic synthetic techniques to synthesize any organic or inorganic molecule. Now that time we have synthesized inorganic molecules like ferrous sulfate and alum and all that, but here in the case of practical of medicinal chemistry 1, we are going to synthesize some of the intermediate compounds or some of the drug molecules. So here we are going to synthesize the benzimidazole from orthophenyline diamine. And the reference book or the reference material for this particular synthesis is, we are going to refer the medicinal chemistry 1 practical book. Now, what will be the principle of this particular reaction mechanism? So the preparation of this benzimidazole, see, this is a ring closure reaction by using an orthophenyline diamine. So this preparation of benzimidazole done by reaction of this orthophenyline diamine with a formic acid in the presence of sodium hydroxide. So what happened? This is going to be an condensation reaction of formic acid with orthophenyline diamine, in which the orthophenyline diamine, see this is an structure of orthophenyline diamine, which are going to condense with the formic acid in the presence of sodium hydroxide. So simply one carbon atom is made available by this formic acid, and this are going to close the ring. So in this way, so this is a simply ring closure reaction for the synthesis of benzimidazole. So very simple reaction. Here we are going to synthesize benzimidazole from the orthophenyline diamine. Now this is particularly an base catalyzed reaction, requires the presence of sodium hydroxide. Is it clear? So simple reaction from the synthesis of formation of benzimidazole from the orthophenyline diamine. So we'll see the procedure. What will be the procedure we are going to follow for this particular synthesis? So we are going to place 27 grams of orthophenyline diamine in the round bottom flask. To it we are going to add 250 ml of so round bottom flask we are going to take is 250 ml. So for that starting material, that is orthophenyline diamine, we have taken 27 grams. In that we are going to add 17.5 ml, that is approximately 16 ml of formic acid. Now formic acid is used as a ring closure reagent. So this particular mixture, that is orthophenyline diamine 27 grams and 17.5 ml of 17.5 gram, that is according to density. So what will be the formula for the calculation of ml quantity of formic acid? Density is equal to mass upon volume. So by using this formula, we are going to calculate the quantity of ml quantity of formic acid, 90%. So this mixture we are going to heat in a mixture of water bath at 100 degrees centigrade for 2 hours. So simply heating we are going to provide for the orthophenyline diamine and formic acid. Now this reaction mixture we are going to cool, and to it we are going to add 10% of sodium hydroxide. So after cooling, we are going to add 10% of sodium hydroxide slowly with a constant rotation of the flask. After 2 hours of heating of orthophenyline diamine and formic acid, in that we are going to add 10% sodium hydroxide solution, as it is a base catalyzed reaction, with a constant rotation of the flask until the solution will be an alkaline to the litmus solution. Because earlierly we have used formic acid and we are making the solution alkaline with the help of sodium hydroxide. So until the solution gives an alkaline response to the litmus paper, we have to add the sodium hydroxide solution, and by constant rotating the flask. So there will be an formation of benzimidazole solution. So whatever the product will be formed, we are going to filter off the crude benzimidazole by using that is pump, and we are going to wash that synthesized benzimidazole with ice cold water. Now, this is a procedure for synthesis of benzimidazole. Now, as we have synthesized crude benzimidazole, we have to recrystallize the product for the purification. Now, the recrystallization procedure for this particular synthesized benzimidazole is, we are going to dissolve the synthesized product, that is which one? Benzimidazole, in the 400 ml of water, boiling water. And in that boiling water, we are going to add 2 grams of decolorizing carbon, that is charcoal, and keep it aside for 15 minutes. Now, after 15 minutes, the impurities which are there in the crude benzimidazole, they are adsorbed on the decolorized charcoal. Now, we are going to filter this solution through the Buckner funnel by using a pump. And after that, cool the filtrate to about 10 degrees centigrade. The whatever filtrate solution we are going to get, that filtrate solution we are going to cool up to approximately about 10 degrees centigrade. And then filter off the benzimidazole, which is a recrystallized one, wash with the cold water, and we are going to dry it in an oven at 100 degrees centigrade. Now, the synthesized yield of recrystallized product of benzimidazole is 25 grams, and the melting point, which is a recorded one, or it is recorded in the official books of benzimidazole, is 171 to 172 degrees centigrade. So this is a procedure for synthesis of and recrystallization of benzimidazole. Now, the calculation part which is involved in the synthetic or synthesis of benzimidazole is, see here, we are going to take, what will be the starting material for this synthesis? We are going to take orthophenyline diamine as a starting material. So, orthophenyline diamines gives how much amount of yield of benzimidazole. Depending upon that, we are going to do the calculations. So what will be the molecular formula for this benzimidazole? The molecular formula for benzimidazole is C6H8N2. So from benzimidazole, how much amount of from orthophenyline diamine, how much amount of benzimidazole we can synthesize? Depending upon that, we are going to calculate the yield of the benzimidazole which is synthesized. Now, we know how much quantity we have taken for the synthesis. We have taken see, we have taken 27 grams of orthophenyline diamine. So, 27 grams of orthophenyline diamine. But for the calculation, we are going to calculate first of all the molecular formula, or we have to write the first of all the molecular formula of benzimidazole. So, what is the molecular formula for orthophenyline diamine? So, what is the molecular formula for orthophenyline diamine? It is C6H8N2, from which we are going to synthesize benzimidazole having a little bit change in its molecular formula, that is C7H6N2. Now only we have added one carbon atom from the formic acid. Now, what will be the molecular weight of orthophenyline diamine which we have used for the synthesis? That is 108 grams, and the molecular weight of benzimidazole is 118 grams. So we are synthesizing benzimidazole, that means 108 gram of orthophenyline diamine is going to form 118 grams of benzimidazole due to the condensation reaction with the formic acid in the presence of whom? In the presence of formic acid. Now, So by therefore, what or how much quantity we have taken for this particular synthesis? We have taken 27 grams of orthophenyline diamine. So if 108 grams of orthophenyline diamine gives 118 grams of benzimidazole, therefore 27 grams of orthophenyline diamine gives how much amount of benzimidazole? So here we are considering the quantity of benzimidazole is in X. So X is equal to, by cross multiplication, we can get the theoretical yield of the benzimidazole. And the theoretical yield of benzimidazole is 29.5 grams. So this is theoretical. By calculation, we have calculated the theoretical yield of benzimidazole. So by doing calculation, आपण किती amount ची yield obtain केली आहे with respect to the benzimidazole? It is 29.5 gram. But this is theoretically by calculation. Now, how much amount we can get from the practical? So that practical yield we are going to write here, and we have to determine the percentage yield of the product. Now, what will be the percent yield of the product? So percentage yield is equal to practical yield divided by theoretical yield multiplied by 100. So this percent yield you are going to report in the exam also and in the your notebook also. So here, how much amount we are going to synthesize after drying, after recrystallizing, that pure products quantity we have to write in the grams, and that how much amount of grams. Suppose for example 20 grams we have synthesized. So 20 gram divided by 29.5 gram multiplied by 100, and whatever result we are going to get, that result we have to report that percent yield of benzimidazole is that much amount of gram. So result we are going to submit in this way. The benzimidazole was synthesized from orthophenyline diamine and it is submitted. Now, this is the synthesis of benzimidazole from orthophenyline diamine. This is our first experiment. Now, our second experiment is synthesis of Benz triazole from orthophenyline diamine. So, how we are going to synthesize the Benz triazole from orthophenyline diamine, and also we have to report the yield of the Benz triazole. Now, our next synthesis is synthesis of Benz triazole. Now, so the aim of this particular experiment is to synthesize and submit Benz triazole from orthophenyline diamine, and you have to report the yield of the product or synthesis. Now, the reference for this particular synthesis is the practical book by Medicine Chemistry Dr. Devla Rao, and a comprehensive practical organic chemistry by Aluwalia. So both of this, by using both of these reference books, the procedure is there. So what will be the principle for the synthesis of Benz triazole from orthophenyline diamine? See, in earlier case, we have used same orthophenyline diamine and synthesized benzimidazole. Now we are synthesizing Benz triazole. See the structural difference between the benzimidazole and Benz triazole. Benzimidazole is going to have only 2 nitrogen atoms, and here there is presence of carbon atom. And here in the case of Benz triazole, we are synthesizing or we are replacing that carbon atom also with the nitrogen atom. See, such a type of substitutions or replacements are known as bioisosteric replacements, which we have discussed in the medicinal chemistry theory. See, earlier case मध्ये आपण काय केलं, orthophenyline diamine by reacting with formic acid in the presence of alkaline solution, we have synthesized benzimidazole. So we will go back to the benzimidazole. See, this is the structure of benzimidazole. Here there is presence of carbon atom. And in the case of Benz triazole, this carbon atom is also replaced with nitrogen atom. So we have synthesized Benz triazole. So such a type of replacement, such type of substitutions are known as bioisosteric substitutions. Now their Benz triazole property is totally different. Benzimidazole property is totally different, but there is slight change in its structural formula. So where we are from orthophenyline diamine, we are synthesizing Benz triazole. Now what is the procedure? This is also an ring closure reaction. The sodium nitrite will react with a glacial acetic acid and liberate nitrous acid. So before we actually go for the conversion of orthophenyline diamine into Benz triazole, we will do some structural or we will do some chemical changes. That is, when sodium nitrite will react with acetic acid, it is going to form nitrous acid and sodium acetate. And when the orthophenyline diamine react with nitrous acid and produce diazonium ion. So when this orthophenyline diamine react with nitrous acid, so it is going to produce the diazonium ion, and this stereochemistry of diazonium ion, they are basically stable. Now this diazonium ion which is formed, see, this is an diazonium ion by reaction of this nitrous acid with orthophenyline diamine. So this nitrogen atom from this nitrous acid will forming a double bond with this orthophenyline diamine's amine group, which is at ortho position. Now after that, this diazonium ion is quite stable in nature because now with the help of, as these diazonium ions, nitrogen is stable, this nitrogen atom will going to attack on this diazonium ions, nitrogen atom, and they are going to form the intramolecular nitrogen coupling reactions. And due to the C, one nitrogen and this is another nitrogen. So both of them will form a coupling reaction within itself, that is intramolecular. Within the molecule, the nitrogen is going to couple. This nitrogen is going to couple, is going to form the covalent bond with this nitrogen also and the another nitrogen also. So this is an intramolecular nitrogen coupling which is occurs and forms the product, that is benzimidazole, by removal of hydrogen atom. So one of the hydrogen atom here it is removed and there is ring closure, intramolecular coupling reaction to synthesize Benz triazole. Now what will be the procedure we are going to follow for this particular synthesis? So the procedure is dissolve 1.3 gram of orthophenyline diamine in a mixture of 1.5 ml of glacial acetic acid. So 1.3 gram of orthophenyline diamine we are going to dissolve in 1.5 ml of glacial acetic acid and 5 ml of water. Stir this reaction mixture until all the solid of orthophenyline diamine is dissolved. After that, warm them gently if necessary to dissolve the orthophenyline diamine. Now, then cool the mixture to 15 degrees centigrade and stir well. Add a solution of 2 gram of sodium nitrite in 2 ml of water. So the reaction mixture will become warm within 2 to 3 minutes and reach a temperature of about 85 degrees centigrade and then begins to cool. So when we have added 2 gram of sodium nitrite into ml of water, then heat the reaction mixture for 2 to 3 minutes till the reaction mixture is going to reach a high temperature 85 degrees centigrade. And after 85 degrees centigrade, we are going to cool this reaction mixture. So color change from the deep red to pale brown will be there due to heating the mixture with a continuous steaming of 15 minutes till the 85 reach temperature will be fall down to 335 to 40 degrees centigrade. And after that, we are going to chill this reaction mixture for ice bath 30 minutes. So we will get a product of Benz Triazole. So we are going to filter this product and wash it with cold water. Now, what are the uses of this Benz Triazole? This is used as a bulk drug industry for the preparation of another drug molecule as an important intermediate compound. For synthesis of large variety of drug molecules, this Benz Triazole molecule is used as an intermediate compound. Now, a very important drug molecule, that is sitagliptin. Sitagliptin is used as an anti-diabetic agent for the treatment of diabetes. Now, this sitagliptin is used, or the sitagliptin is synthesized by using this intermediate product, that is Benz Triazole. So, it is the basic nucleus present in the anthelmintic drug. Now, while synthesis of mebendazole, thiabendazole, the categories of mebendazole and thiabendazole, they are used as an anthelmintic. And for the synthesis of mebendazole and thiabendazole, we are using this Benz Triazole as a starting material. Now, after synthesis, we are going to record the yield of Benz Triazole. It is prepared and submitted, and the percentage yield is yield divided by theoretical. Now the calculation part of orthophenyline diamine, which we have used synthesis. So we all know the molecular weight of orthophenyline diamine is 108 grams. Earlier we have calculated. Now here you have to calculate the molecular weight of Benz Triazole. Now, how come we are going to start the calculation? How much amount of orthophenyline diamine we have taken? So that much quantity here we are going to write. Depending upon that, will gives how much amount, the whatever molecular weight is there. So 108 gram of orthophenyline diamine gives how much amount of Benz Triazole. Here we have to write the molecular weight of Benz Triazole. But we have taken 1 gram of orthophenyline diamine. So how much of Benz Triazole is prepared? So whatever calculation by cross multiplication is coming, this is the theoretical yield for the calculation of Benz Triazole. Now after that, practically whatever synthesized product we are going to take, we are going to filter out. That is nothing but the practical yield. So we are going to calculate the practical yield divided by theoretical yield multiplied by 100 for the calculation percentage yield of Benz Triazole. So this is an second experiment in which we are going to synthesize the Benz Triazole.